All right, good morning, guys. Happy Tuesday. Reminder that we will have our class meeting today at 10 o'clock. So now we are going to continue working with our achievement level descriptors. Today we're looking at the level 4 questions. So these would be questions we would need to get right to score an FSA level 4. Again, we have a reminder of what the different properties of multiplication are up here. So if you've forgotten what one looks like, they have examples up here. So what we're looking for today is determining an appropriate strategy or multiple strategies for a given situation. So here we're just trying to find good ways to solve it. This is more focused on us being efficient and doing things the best way and the easiest way than it is us doing big crazy operations. Here they're just looking for us to kind of show that we know our stuff. Let's look at question number 1. It says 5 times 10 is 50. Okay, yeah, that's legit. Select a related number sentence that also represents the product. All right, also represents the product. If I have forgotten what the product is, that sentence is like gibberish. Luckily, I remember the product is the answer to a multiplication problem. Therefore, the product is 50. I'm looking for things that equal 50. Now, I also noticed it said select A, so I'm only going to have one answer. All right, 10 plus 4, 14, definitely not. I can skip count by 5s, or I can count them and just go 1, 2, 3, 4, 5 times 5 is 25. However you want to approach that problem. 10 times 10, that's 100. And here we have 10 times 5. Well, that's 50. So I am now going to erase, and I'm going to scroll down to question number 2. All right, select all, there it is, of the number sentences that have the same value as 7 times 5. Okay, well, finding out the value of 7 times 5 sounds important, so let's skip count by 5s. 5, 10, 15, 20, 25, 30, 35. Oh. So I'm looking for things that equal 35. Remember, always do your parentheses first. Always. No matter how tempting everything else looks, the parentheses go first. All right, that's 5. And 7 plus 5, well, that's 12. So not A. All right, 5 again. Well, 7 times 5, that's our original problem. That's 35. Because it's 7 times 5. 7 times 5 is 35. It's the exact same problem that's right here. All right, 5 times 4, that's 20. Plus 5 times 3, that's 15. Well, 20 plus 15, that's 35. Okay, 7 times 2 is 14. Plus 7 times 5. Well, if I'm looking for things to be equal to 7 times 5, how can I add anything to 7 times 5? Adding something to 7 times 5 will make it too big. It can't work. It's not D. And then 5 times 3 is just 15. So our only answers for number 2 were B and C. All right, question number 3 is cut off a little funny because they have it right here on the page. And then the actual problem is down here. So this is one of the nasty ones where they give us this long list of numbers in the box. However, we want to match the numbers to the boxes to create a different expression that is equal to 2 plus 3 plus 4. The nice thing is when my problem is just addition, I don't necessarily need to pay attention to the box. Because to create a different expression that is equal to 2 plus 3 plus 4, well, I can use the associative property of addition, and I can just mishmash my numbers around in any different order. I can completely disregard this box and ignore it, and I can say, well, I'm going to do 4 plus 2 plus 3, or I could have done 4 plus 3 plus 2. You can have some fun with the order of this. But all you have to do when it is addition or multiplication, it only works for addition and multiplication, is take the same set of numbers and wiggle them around. If you are subtracting or dividing, you cannot do that because there is no associative property with those operations. If you do things in a different order with subtraction or division, you're going to get different answers. But no matter what, if we multiply 1 times 2 times 3 or 3 times 1 times 2, the answer is still going to be the same. Let's take a look at number 4. Which of these are ways you can break apart a factor to solve 6 times 3? All right, again, I'm going to solve 6 times 3. That's 18. Circle all the correct answers. So I am looking for things that equal to 18 because something that FSA loves to do, because next year there will be FSA, we've avoided it this year, but we can't dodge it forever, unfortunately. They love to give you factors that don't look like your problem. That is why the most important thing you can do when you have these problems, find out what it's equal to, and then add up your answers. When they are the same, that is a correct answer. When they are not the same, it is wrong. It is easier than trying to go and factor 6 times 3, because look at A. It has 3 times 3 is 9, and 3 times 3 is 9. We don't naturally want to break 6 times 3 into 3 and 3 and 3 and 3. However, I know 9 and 9 make 18. Because when we see this and sign in the middle, what they're asking us to do is add. Every time you see this and in the middle, they want us to add the numbers up. Whenever you see these problems, and is a plus sign. So they're saying 9 plus 9, well, yeah, that's 18. This is what I mean about the way they break up the numbers. It's kind of weird, but when you look at the answers, 18 is 18. That's all we're looking for. We're looking for things that make 18. So let's look at B. We have 3 and 6. That does not make 18. Okay, 12 and 6. Oh, that makes 18. 12 plus 6 is 18. Okay, here we have 12 and 12. That is too big. Okay, we have 6 and we have 12. That's 18. So for this one, our answers would be A, C, and E. When you have problems that look like this, you want to look for the equal, because the only number you're concerned with is actually the one that's right behind the equal sign. They are giving you these long strings of numbers to be confusing, and it's working. It's confusing to look at it this way. Zoom in on the numbers behind the equal sign and add them up. When you do that, look how easy this became, because then it was just adding very simple numbers. But when you get into all the 6 times 1 stuff, trying to figure out if you can combine it, that's a lot more work for your brain. It is really easy to say, well, these are 18, so that's equal, and this is 24, so that's not equal. That's how you want to approach these problems. That's a strategy that we want to use. All right, and I totally thought there was a 5th problem, but there were only 4 today. Ha! I will see you guys at the class meeting.